Okay, this presentation is going to go over the notes for Unit 9, where we're talking about different types of energy as well as the law of conservation of energy. So the first part of your notes just asks you to define energy. So energy is just the ability to do work. If you think about if you have to go run a mile, right? If you're really tired, if you haven't eaten in a while and you don't have any energy, you're not going to go run a mile or run 2 miles. You're going to just want to sit on the couch and not do anything, right? Virtually do nothing. So if you have to do work or, move around, get up and do things, you have to have energy. So that's kind of the basic premise of this definition. It's just the ability to do work, to move. The two types of energy, we have potential energy, which is just stored energy, and then we have kinetic energy. Any time an object is moving, its kinetic energy is greater than its potential, just like you saw in your simulation. You saw when the skater, was moving quickly at the bottom of the ramp, his kinetic energy was higher. Whereas at the top of the ramp, when the object wasn't moving, when the skater wasn't moving quite as fast, his potential energy was actually higher. So usually we can think of it like potential is more of a stationary. So when you're not moving, not moving. And then obviously our kinetic is when we're moving, okay? And feel free to pause if you need to finish up any notes as we go along. So there's two factors that affect our kinetic energy, okay? So this is kind of what I mentioned earlier. When your radar was at the bottom of the ramp, right? What did you notice about his kinetic energy? Right? We should have seen that at the bottom of the ramp, he was moving a lot faster. So when he was down here, right, our kinetic energy was really high, right? And our potential energy was really low. Okay. So we know that, how fast we're moving kind of affects our kinetic energy, right? You were looking at one other factor when you were kind of determining what affected your kinetic energy, how much energy your skater had, and that was your mass, right? So you should have noticed a difference when you had a small mass versus a large mass. Okay, what kind of difference in energy did you notice for that? Think about your answers to those questions. Okay, so in your notes, you can kind of fill out the two factors that affect our kinetic energy. We have velocity, right, which is just our speed in a direction. So how fast we're moving. If we're changing direction. And then our mass, right? That's going to affect our energy that we have. Okay. So what you should have seen is that our total energy stayed the same the whole time, right? Stays the same. And then our kinetic energy and our potential energy are the energy types that are changing. So here, like my potential energy, when it's really high, my kinetic energy is going to be really low. So probably here, what's happening is my object is still or not moving. Okay, because we said, remember, kinetic energy is motion. So if it's zero, basically, that means that the object is not moving. Okay, but it still has energy. It's just stored inside. Okay. Down here, where our potential energy is 0 and our kinetic energy is the highest, this probably means that we're moving quickly. kind of like the skater at the bottom of the ramp, okay? It doesn't have, the energy isn't stored. The energy is actually being used to move really fast. And then I think there's a section in your notes about how does mass affect potential energy and how does velocity affect our potential energy. So we can see here, based on this graph, that when our velocity is low, our potential energy is low. When our velocity is high, when our velocity is low, our potential energy, let me erase this, is high. They're kind of opposite. When our velocity is high, like up here, right, we're moving quickly, our potential energy is low. So those have an indirect or inverse effect. Your mass, however, is going to affect our potential energy greatly, okay? So your skater, you should have seen how when you made the mass large, so let's go up here, I'll write up here. Sorry, when the mass went up, your potential energy went up. When your mass was down, the potential energy was down, okay? And that kind of was related to the total energy as well, okay? This is kind of, our potential energy is kind of what affects our total energy. So these have a direct relationship because they're going to move together. As mass goes up, so does the potential energy, okay? So let me kind of fix this here so you can read it. So velocity and potential energy is inverse or opposite, and mass and potential energy is direct or the same. All right, so the law of conservation of energy, guess what? It's another conservation. So remember, whenever we're saying a law of conservation of something, we're just saying it can't be created or destroyed. So our law of conservation of mass cannot be created or destroyed. Our law of conservation of momentum cannot be created or destroyed. Law of conservation of energy cannot be created or destroyed. Okay. However, with energy, we're going to actually look and see how it can actually be converted or changed into different types of energy. Okay, so how does your cell phone light up on the screen, right? Well, it's taking energy from the battery. Well, how does your battery get energy? Well, it's taking energy from the outlet, the electrical outlet. Okay, all of those are different types of energy, but they're still energy. Okay. So another example is just like lighting a match. So, right, at the end, you're basically, we call it thermal energy because it's hot, right? We know that fire, our end result of lighting a match is fire. It's hot and it's bright. So we have two types of energy, light and heat. Okay, well, where did those come from? How did we get those? Well, there's actually, it's really a chemical reaction. Okay, so there's stored chemical energy inside that match. That's why eventually your match is going to burn up. Okay, eventually it will burn through that, and there's nothing left. Okay, it's used all the energy that's been stored inside it. Okay, so you're just going to use kind of this chart, and we'll talk about them to fill out your types of potential energy. Okay, so we have chemical energy. Chemical energy just has to do with, just like when we talked about chemical reactions, all of those bonds or compounds have energy stored inside of them. Okay, so like for example, if I'm looking at H2O, okay, I have one O, I have some H hydrogen molecules, okay, and inside here, inside these little bonds, there's energy, okay. If I break up this molecule, right, I'm going to release energy or absorb energy. And so usually when we're talking about this chemical energy, we're looking at like exothermic reactions that are going to release energy or release heat. Elastic, this is like a rubber band or a bow and arrow or a slingshot. How are you getting that arrow to move or that rock to move, really far away? Well, when you're stretching out that elastic band, you're actually increasing the amount of energy that's stored there. And so when you let go, that's going to that kind of affects how much, how far, right? How much moving that object can do. So that's our elastic energy. Gravitational is energy that's stored in objects that have been lifted off the ground. So it has to do with kind of battling that gravitational pull. And I know we don't feel it because we don't really feel the effect of gravity when we're just standing on the surface. But when we're really walking up a high mountain, or if you're walking up a hill, or you're walking upstairs, you're really counteracting that gravitational force that's pulling you down to earth. Even though we don't really feel it on our bodies, it's there. And so we're actually, it takes more energy to kind of counteract that gravitational force than not. So all we're saying here is that the higher up you go, the more potential energy you have. Okay. So like the roller coaster, all right, this has high potential energy. This has low potential energy. Okay. Nuclear is like when we talked about nuclear energy and nuclear reactors. This is just that energy that's stored inside the nucleus. Okay, remember we talked about how when those radioactive elements decay, like uranium, it's releasing energy, and we use that energy to make electricity. Okay, so we've kind of already talked about a couple of these things, actually. Your kinetic energy, we're going to kind of come back to mechanical here in just a minute, so we're going to skip over that. It's kind of classified as kinetic. But we also are going to kind of call it its own. We have a little bit more to say about it than just this, so we're going to come back to that. But we have electrical energy. So this is energy, right, of anything that's moving. So you can kind of think about it. If it's moving, it's going to be in the kinetic category. So electrical energy, right, that's just energy that travels through wires. And you can, even though you can't imagine it, like you may not be able to see that electricity, we still know that it moves, right? Because that's how it moves through the power lines, right? It moves through the cord from your wall to your phone. So it's moving. Light energy, sometimes you'll see this as radiant. This is kind of the fancy word for it. That's just light energy that travels through electromagnetic waves. So any type of light that you see, like visible light, UV light, that's all kinetic energy. Okay, and we know it moves because it's moving like as fast as the speed of light. Okay, we know that light moves. A heat energy or thermal energy, anything that's hot basically, or heat. Okay, anything that gets hot produces heat. That's our thermal energy. And then sound is the last one. And we know obviously sound moves because you hear it from one room to another, right? So anything that produces a sound, that's sound energy. Okay, that's pretty self-explanatory. So now that you're done with the notes, or actually let me go back to mechanical. Sorry, I forgot to kind of go back to that. Mechanical energy is a little different because we almost can sometimes group potential in with kinetic energy and call it mechanical energy. Usually we're talking about, sorry, it's kind of blurry now, but objects that move. So if we're talking about an actual thing that you can see and touch that's moving, we're going to call it mechanical energy. Okay, so like when you're running, that's mechanical energy. When you're driving a car, right, the car is moving, that's mechanical energy. The windmill, right, the windmill is moving, that's mechanical energy. The dog is running, mechanical energy. Okay, and so we kind of anytime you're thinking of an object or like a person or a thing, like here's some people, right? A car. Here's a fan, you could think a fan or a windmill, right? Those are all mechanical. Okay. So just make sure you understand that. All right, we're going to come back to work in a couple days. So we'll fill out this last little section here in a couple days. So don't worry about that right now. We'll just skip over that. And so now you're going to turn over to the back of your notes and you're just going to complete the little practice questions, okay? What it is you'll see, if you turn to the back, you'll see how it's basically like a ball is rolling on a ramp, similar to the ramp like that your skater was riding on. And so you're just answering questions about the kinetic and the potential energy of that ball at different points in time. So at different parts on the ramp, how does it connect? How does its kinetic energy compare to its potential energy? Okay, so you're working on that, and then you can glue this in your notes when you're done with the back page.